Section 2.2, we're going to work a lot with graphs, in particular, how you can graph things and also find tables of values. Some of the basic graphs that you should know would include these four: graph of the square root function, the absolute value, x cubed, and x squared. If you follow the Desmos link in the notes, then you can find your way over this page here, practice along. The first graph, kind of grows slowly. It starts at 0, of course, because we can't take the square root of a negative number. So 0 is as far to the left as this goes. Graph of the absolute value is next. I'll shut off this one, turn on this one. You'll see that it has a nice sharp point at the origin. That's called its vertex. And it's symmetric around the line x equals 0, also the y-axis, or commonly called the y-axis. If you fold this across the y-axis, it'll land on itself. So it's got that nice symmetry, as does the graph of y equals x squared. The big difference that I want you to notice is that there's a smooth vertex here as opposed to the pointy vertex with the graph of the absolute value. It won't make a difference to you now, but later on in calculus, this graph here will not have a derivative at 0. Moving on, you've got the graph of the cubic function, which kind of wiggles its way through the origin before heading up towards positive infinity and down to the left towards negative infinity. Now, I do want to say one more word about the graph of y equals the square root of x. It kind of might look like half of a parabola if you look at it in comparison to, say, maybe this. And if you're thinking that, then your intuition is not far off at all. Let's take a look at what we can do with this equation. If I were to square both sides of this, something like this, then what happens when I square the square root of something? Well, those two operations just cancel each other out. Now, unlike your graphing calculator, the cool thing about Desmos is that it can actually graph something like this. So let's put that in right here. We're going to graph my equals, actually, I want y squared. So let me go up here and use that to get my exponent. Y squared equals x. And there you go. So basically, it's just a sideways parabola. And if you were to take the square root of this, you get half of that. If you want the other half, you put a minus out in front. Minus gives you the other half. Nice. Okay, so what about all this stuff are you going to have to work with? Well, you're going to have to try and create tables of values to work with your functions. So in particular, let's take a look at this one. F of x is 6 minus 2x. You might have to work with that. Then, well, there's a couple things that you could do to help fill out this table without plugging these in yourself and doing the manual calculations, which of course you could do. So let's start by plugging in y equals 6 minus 2x into our graphing calculator. I'll just clear this stuff out. So to see that, it's 6 minus 2 and then x right there. Before we ask our graphing calculator to do a table, I want to check that our table settings are correct. So if you hit the second key, then the window key, make sure that your independent is set to ask. So if it's flashing auto, then move over to the right and press enter. Dependent, make sure that's set at auto. Once those settings are in place, you can hit the second key, then the graph key, and start typing in some numbers. And we wanted numbers that were starting at -2 all the way up to 4. The great thing is you can just type these in, say -2, enter, -1, enter, and so on. 0, 1, 2, 3, and 4. So beautiful. Those are all your points. And then you can use those points to fill in that table. And eventually we're going to have to graph that. Now, it's wonderful doing it on a graphing calculator. We're going to use Desmos a lot as well. So let me show you how to use it on Desmos. There's a nice testing mode on Desmos that I hope that we can use this semester. So I'm going to shut this graph off. And down here, where I put in a table, you put it in a table by hitting the plus key and then add yourself a table. Well, maybe I'll do that. So the X value that I want to type in is -2, but my Y value has to come from my function. So that was 6 minus 2x. So I'm just going to erase this. I'm going to do 6 minus 2. And then I need to type in this, x2. So I can copy that, paste it there. Or if you simply just type in an x and then a 2 immediately afterwards, it does the same thing. Now, the cool thing about Desmos is this. If it detects a pattern, like the next one, I'll type in -1. And it says, okay, if you want to just keep on incrementing by 1, I can do that. So all I did was I hit enter. I'm going to hit enter again and again and again and again. And it shows you the graph. Pretty nice. Let's get rid of this, move that down. Nice. If I actually just wanted this graph itself, I could do that. So I'll just go up here and type in enter, y equals 6 minus 2x. Beautiful. What about if you're entering the graph into WebAssign? Well, let's take a look at that part. So I'm assuming that you can enter in these values. To do graph on WebAssign, click this icon. Now, you've got 3 choices. This one is array, meaning it starts from one point and it just points in one direction. The second one is a line segment. If all you want is just a little portion of a line between 2 points, that's your choice. But I want a line. So what I can do is plot a couple points. Let's see, I've got one at 2, 2, another one at 0, 5. So 2, 2, well, I think those are already plotted. And then, not quite, 0, 5 is about right there. If I put that point there, it gives me this blue highlighted line. Now I can look at that line and make sure that it has the correct points that I wanted, 2, 2 and 0, 5. If I was off by a little bit, then I could correct that here. Maybe I make that a 4 or a 3 or whatever I need to do. I can change that. Let's move it back to 5. And I close that, and there's my line. Beautiful. Okay, so kind of a quick little thing for you working with WebAssign. Let's keep going and look at a few more things and tricks about graphing. One of the types of problems that you're going to be asked to deal with is something like this, where they're going to give you a function and they're going to give you different viewing windows and saying, all right, well, what's the graph that's going to represent or be represented by this viewing window? We'll do it in the graphing calculator first. So let me clear out a few things here. Go to the y equals key. And we're actually going to work with the function 9x minus x squared. So let me clear that out. And I'll clear this out as well. You can follow along with things on the key history by looking here. So I want 9x minus x, and then the square key is on the left-hand side. Now the viewing window is in the upper left. So that says window. And maybe you heard my dog Aspen, he's saying hello to you. He commiserates with you. He has to listen to me a lot more than you do. So this shows you your viewing window. Currently it's -10 to 10 on the x-axis and -10 to 10 on the y-axis. That's actually one of the viewing windows that we want to look at according to our problem. So we're going to have these viewing windows. So let's just take a peek at what it looks like. This is the standard viewing window. So if we wanted to look at it, the standard viewing window, you can quite easily. I'll show you a little trick on that. Well, let's just hit the graph key and see what we get. Feels like I'm missing something here, right? So let's take a look at some of the other viewing windows. The first one was -5 to 5 on the x-axis, -5 to 5 on the x-axis. And then the second part of that is also -5 to 5. And I should point out something here, just to be clear. When you're giving these viewing windows, this is your x min, that's your x max, that's y min, and that's y max. So this is going to be my handy, quick way to write all that stuff without writing the x min, x max, y min, y max. So with those settings, let's hit the graph key. And wow, that looks even worse. So I'm not really happy with either of the first two of these. This one cuts off a lot of the graph. This one cuts off some of the graph. So let's see if we can't do better with some of the other settings. So the next one I want to look at would be this one down here, -2 to 10 on the x-axis and -5 to 20 on the y-axis. So we'll go back to our window. And I'm going to just clear this up a little bit. Window, -2 to 10 on the x-axis. And on the y-axis, -5, which I can leave alone, to 20. And bam. Well, that's looking better. We missed a little bit at the top. So maybe I should make that window maybe 22. Let's see what that does. And that looks perfect. So we're using all or most of the space of our graphing calculator that it provides. And that's a pretty good graph. Now, there are a couple things that we can refine here a little bit. For instance, on the y-axis, there's a lot of tick marks. And if you had to count and figure out, roughly how high that is, it would be kind of a pain. So let's go over to our window key and adjust what's called Y scale. This tells you how far apart the tick marks are on the y-axis. And I'm going to make that a 5. So let's make that a 5 and go back and hit the graph key. 5, 10, 15, 20. Oh, okay, that looks like it's at about 20. And that's much easier to read. It's not nearly as busy. I can do a similar thing on the x-axis. Let's maybe make that a scale of 2. So there you go. 2, 4, 6, 8, 10, etc. So the maximum of this vertex is somewhere here. So someplace to the right of 4, maybe 4.5, probably be the exact value. Now there is one more window that we can look at, -10 by 10 and -100 by 100. So let's look at that one. So -10 on the x-axis, 10 on the y-axis, and -100 here, and 100 for y max. Now, I probably don't want to leave y scale as 5 because there's going to be an awful lot of tick marks then. Well, let's just take a look at it and then I'll go back and adjust it. All right, not a real good graph. It's cutting off some of the interesting part, and this top part is really wasted space. Let's go back and adjust the window, something a little bit bigger that evenly goes into 100, or at least helps us count near that high. Maybe you want to go 20 or 25. At least that's a little bit more legible. You just have to keep in mind that the scale on the y-axis is units of 25. So which one did you like best? Yeah, if we make that a 2, then definitely this one is the best. Not so much. Now, you can do a similar thing on Desmos. So let's take a look at that. And let's see. Let me shut off these graphs. So I'll just click that and click that. And guess I'm gonna need to add that one in. So I'll just come here and yeah, go here, press the enter key, and it gives me another box. I want to graph or work with the graph of, and we'll do y equals 9x minus x squared. You can get an exponent by hitting the shift key and then a 6. That'll put something up into the exponents. To control the viewing window, go over here to this icon, the tool icon, and just adjust your axes. So you can do the same thing that we just did. Let's see, our favorite one was -2 to 10 on the x-axis, and -2, let's see, we know -5 to 22 on the x-axis. So there you go, you got a nice graph that fills up the frame. And in a similar way, you can check the other viewing windows that you have to work with. Nice. Now, on an exam, we're going to have a way to use Desmos. If you want to download the Desmos test mode app to your phone, then that'll give us a way to use Desmos during an exam, which would be really cool. So I'm looking forward to that. But in the meantime, the next thing we got to cover is piecewise functions. So what on earth do I mean by piecewise functions? Well, let's take a look here. Piecewise functions. Well, sometimes I don't want all of a function. Sometimes I just want part of it. So for instance, let's see. Here's a line y equals 8. Just a nice horizontal line, no big deal. And then here's another line, y equals x minus 1. But sometimes I only want part of a graph and part of another graph. And if I put those two parts together, I get what's called a piecewise function. So let's take a look at the piecewise function, or similar to one that you're going to have to deal with in the homework, which is f of x, which is 8, as long as x is less than or equal to 3, and x minus, what was it? X minus 1 for x greater than 3. So really what I want is this. I don't want this entire line. I only want to draw it up until right here, x equals 3. So let me get rid of this. And instead, I'm going to draw y equals 8. Then I got this fancy notation here, x less than or equal to 3. And notice what happens. My graph stops right there at 3, 8. And what I want to do after that is for x greater than 3, I want this graph. So let me shut off this one. And really, I only want this part of the graph that starts right here at 3. I want everything to the right of that, which reflects x greater than 3. So we'll shut this off and turn this on, and bam, there you go. That's your piecewise graph. So if you had to evaluate a function, you could do it in a couple different ways. For instance, let's find a couple values. I could have to find f of 1 and f of 5. If you look at f of 1 says, well, since 1 is less than 3, I want to use this part of my function. That is, f of x would equal 8, or f of 1 would equal 8. If I'm dealing with x is 5, then I want to use this part of the function. Since 5 is greater than 3, well, putting in a 5 here, 5 minus 1 gives me a 4. Now you can see those points on the graph as well. So at x equal 1, yeah, right there, I'm coming close. Tough to get it completely dialed in, too far. In any case, there's 1 and 8, and then at x equal 5, There we go, 5 and 4. At least I got that one spot on. So that's the visual that goes along with the actual calculation down here. Now, the big question is, well, how did I do those things? I use these curly braces to kind of limit things. And it's a little bit easier to do in Desmos than it is to do in the graphic calculator. Well, I'll show you how to do that in just a minute. So if you want to limit a function, let's go back and take a look at a different function. Let's say y equals x squared. And I want a 2 up there. Maybe I only want this graph for values of x greater than or equal to -2. Well, when you want to limit that function, use a curly brace. It should be next to the p, and you have to hit the shift key to get that. I'll just type in x greater than. Now you got two choices here. If I want greater than or equal to, you can just type in those characters one right after the other. The greater than, and then hit the equal to, and I'll just put it underneath there. And then type in -2, and there you go. You've got a piece, well, you've got a piece of this graph that starts at -2. I could have, had I wanted to, let's type in this function again, y equals x squared. Gotten that greater than or equal to or less than or equal to sign a little different way. Again, I'll type in the x. This time I want it to be less than, say, -2.5. So you can come over here to this little keyboard and use the less than or equal to or greater than or whatever one you want. Less than or equal to -2.5. The reason I did that is just to leave a little gap here to show you that I'm defining these things in kind of a piecewise function or fashion. There are other ways to define piecewise functions in Desmos, but I'm not trying to make you an expert in Desmos. I'm just trying to help you learn how to graph these things. Let's see how we do that in the graphing calculator. So let me clear this out. If you go to the y equals key, let's clear this out. And I'm going to first start by graphing y equals 8. And let's see, let's set up our window so we can graph this. I don't think I need to go from -10 to 10 and -100 to 100. So a quick way to get to what's called the standard window is to hit zoom 6. And that just sets it up on the x-axis from -10 to 10 and on the y-axis similarly. Okay. But going back to our problem, we only want the graph of x equal 8 for x less than or equal to 3. So how do I tell the graphing calculator I want this for just x less than or equal to 3? Do me a favor, hit the divide key right here. I'm not going to do that just yet, but hit the divide key and then type in what follows as I do it. So hit the divide key and type a left parenthesis. We want to tell the graphic calculator that this is for x less than or equal to 8. So sorry about that. Type in the x, and then to get the less than or equal to, hit the second key, then the test key, and there you go. Number 6 is your less than or equal to, less than or equal to 3. So when I hit the graph, it's going to graph this function only up till x equals 3. Now what this does is, this is just kind of like what is called an indicator variable. It's either got a value of 1 or 0. So if it's a 1, then you get 1 times 8, it's going to graph 8. If it's not true, then you get a 0. 0 times 8 is going to be 0. So you get this kind of weird step function where it's here and then it's down here. I don't want that part. So what I'll do, and the easy thing for you to do is just when you're typing these conditions in, hit the divide key. Second, insert, divide key. Because now when this is false, you're dividing by 0 and it can't graph it because it's undefined. So there you go. That's what you want. Let's add in the other part of this graph, which is parentheses x minus 1 divided by, and here I want x to be greater than 3. So I'll put in my parenthesis there. Then x, go to the test menu. Let's just clear this out. It's getting a little bit busy. Second test. This time I want x to be greater than 3. So I'll type in 3, and then 3 again. And that should add to my graph. Perfect. There's your piecewise function. Nice and simple. So on a test, you're free to choose which one you want to use. I mean, personally, I think Desmos is easier, but hey, whatever works for you. Now, there are just 2 last little topics I need to cover to help you through this section. So let me do that. And really, they're just kind of reminders of things that you did in Math 1150. So let's work on those. And those reminders are to really decide when something is a function. So in order to be a function, something has to pass the vertical line test. Vertical line test. What's the vertical line test? A vertical line drawn through the graph anywhere can only touch the graph at most once. Any vertical line on a graph can touch the graph at most once. At most once. If it touches more than once, it's not a function. If the graph is intersected more than once, the graph is not a function. All right, so let's do a couple examples of that. Let's take a look at these examples. The first one I'm going to graph is going to be a parabola. It's going to be a parabola in y squared, meaning that it's going to open left or right as opposed to up and down. So something like that. So if you were to imagine drawing a vertical line, that vertical line, or most vertical lines to the left of the y-axis, are going to hit the graph at least 2 places, or exactly 2 places. So this is not a function. How about a couple more here? Let's take a look at a rectangle. So I'll draw a little rectangle for our figure here. What else can we draw? Some kind of a cubic function. So something like that. And then one last one, which I don't have a name for this. This is just my whim at the moment. Something like that. Now, I'll give you a second. You can pause the video if you'd like and try and decide which one of these are functions. So if not physically on your paper, then at least mentally, you should be applying the vertical line test and saying, all right, well, if I draw a vertical line, can it intersect the graph at more than one point? And the answer for this case is yeah. You know, in a lot of places it'll intersect twice. And right here on the ends, there'd be an infinite number of sections. So this one is not a function. Not a function. Fails the VLT. How about this one? Did you give that one a pass? I know it's not the best drawn graph, but all the vertical lines here intersect this graph at most once. So this one is a function. It passes the VLT. So we're happy about that one. Now, how about the last one? Last one, well, as crazy as it seems, you know, going up and down like it does seem to pass the vertical line test. So it is a function. Now there is going to be an example on WebAssign where they ask you to graph or decide whether or not something like x equals y to the fourth is a function, or y to the sixth, or y to the eighth, something like that. The problem is most of us, myself included, don't know exactly what this graph looks like. If you were to try and do this on your graphing calculator, it would take a lot of work. You'd have to, first of all, solve for y. So y would be the fourth root of x. And then you have to be savvy enough to realize, oh, there's plus or minus there, and then have to graph those separately. It's kind of a pain. I mean, you could do it, but it's a lot of work. So, but I mentioned my friend Desmos. The cool thing about Desmos is you don't have to have y solved for in order to graph something. You can just type in x equals y, and here I'll use a different key here. If I use this a to the b power, it'll put something up in the exponent, and I can fill in that exponent. Now I can play around with the view on this, but I don't really need to. I think I see what I need to know. Can you tell if this passes the vertical line test? Is this a function? Congratulations if you said yes. Sorry about that. I guess it's time to go. So this is a function, or excuse me, it is not a function. It fails a vertical line test. So that's it. But the important thing is that it's really helpful to look at this. You can play around with the scaling and stuff like that. I'll show you some tricks on that some other time. But clearly this fails the vertical line test. Okay, good luck with this stuff.